All right, so I'm going to attempt a old school style video here, just paper and pen, and have a piecewise function here. The reason I know it is a piecewise function is because you can see that it is made of one linear piece, a completely different linear piece, and then another linear piece. This is one line, this is two, this is three. And I have labeled mine ahead of time here, 1, 2, and 3. But also I've labeled that I'm counting by tens this way and counting by ones this way. Please make sure you pay attention to that whenever you are finding any equation. Make sure you know what you're counting by. So if I'm finding equation number 1, I want to find my slope and I want to find my y-intercept. Notice on that one, it's pretty quick to find the y-intercept because it goes through 0, 0. So I know my b value is 1. My slope, however, I do need to be careful because yes, it goes up 3 over 4. But remember, this is 30 because I'm counting by tens over 4 singles. So it's 30 over 4, which reduces to 15 over 2. So my slope would be 15 over 2. My y-intercept would be 0. That equation would be y equals 15 over 2x. Now you have to pardon me here for a second. I'm going to have to kind of zoom in for just a second here so I can write that and not make it too ugly looking. All right, so now let's look at equation number 2. Equation number 2, same thing. I want to find my y-intercept. I want to find my slope. The problem with this one is, when you look at this, it does not start at 30. That's not the y-intercept. The y-intercept is going to be way down here somewhere because of the shape of this line. Remember, I told you to think about it. If you were to take a ruler across your paper and actually extend that out, you should be able to see pretty close where this one's going to hit. But I want to make sure that I am exactly right. So we use our skills from the previous chapter. To find the slope, we can use our counting skills here because this one goes up 3 over 2 or up 30 over 2. That means my slope is 30 over 2 or 15. So I got my slope. But what I don't have is I don't have my y-intercept. My y-intercept is way down here somewhere. So if I'm coming way down here, I can't guesstimate it. So what we use is we use one of these points, this one here or this one here, and use the point slope form. I personally would use this point here, 430, and use my point slope form. Now I am going to actually take some time and kind of angle this here for just a second so I can actually use my offhand as I drop the phone. So that'll be a classic for you. You can make fun of me in class tomorrow for that one. And again. So we're going to pause for a second there, and we're going to actually, I'm going to write in my slope and my point that I have. Sorry for the dark video for just a second, but this is going to be a little bit easier for me to do this way. So I plugged in my slope of 15 and I plugged in my point of 4 for x, 30 for y. So again, I'm plugging in this point and the slope of this line to find my equation. So I multiply 15 times the x and the 15 times the negative 4, and that's going to end up giving me 15x minus 60. Then I add the 30 over, and that's going to end up giving me 15x minus 30. And if we do look at this guy, if we kind of extend this out with this, it looks like it is going to cross about negative 30 right there. So again, we're finding the equation of that line. We don't care the fact that it is only a piece of that line. We're finding the equation of that line no matter what, the same way we have always found linear equations. So then I go to line number 3. Line number 3 here is up here. Again, I do not have my y-intercept because this line goes all the way across here forever, but I'm cutting it into a piece here and here. Again, the reason they're called piecewise functions. Yes, I can kind of look at this. It looks like it's going to cross here at 30, but let's make sure by actually doing the math. So notice this one goes up 1, which is 10, over 2. So up 10 over 2. So 10 over 2 is 5. So my slope for that line is 5. I also know it's going to hit any of those 4 points there. I'm going to use this point right here, the point 6, 60. So I'm going to show that in just a second. I'm going to do y minus 60 equals 5 times x minus 6. Multiply my 5. Sorry for the blank screen again. Add the 60 over. And that's the same thing I did on equation number 2. I found my slope using the slope formula, or just the points and counting them. I found my y-intercept here by actually plugging in a point and a slope. Same thing I did over here to get 15x minus 30. So again, notice that one, 5x plus 30, the reason it's got a positive y-intercept is because that's where it will hit. But the number 2 equation, the reason it has a negative y-intercept is because that's where it would hit. It hits down below the axis. The reason this one has a 0 x-intercept, or y-intercept, excuse me, is because that's where it hits. It hits at 0. And so now I have my 3 equations. So the final step in a piecewise function then is to tell somebody when to use each equation, or to tell the domain of each equation. So I'm going to write that out here in just a second. I will fill that to you, but also I'll talk about what each part is, just in case you have some questions. Hopefully it will make a little bit more sense. Give me just a moment. All right. So, the first equation starts here at 0 and then goes over here to 4 for x. Again, the domain is 0 to 4, where it starts, where it stops. It ties directly back to all of that stuff that we talked about with actually domain and range, where something's increasing, where it's decreasing. It's the same idea. But this one starts at 0 and ends at 4. So in my first part of my piecewise function, I have y equals 15 over 2x. Sorry for the handwriting. That was my first equation. And I did it from 0 to 4. If you want to use your interval notation here, go for it. Then I did equation number 2. Notice it starts at 4 and stops at 6. But since I already had that point taken care of with the first equation, I can kind of treat it like it's an open dot, even though they overlap each other right there. They actually touch the same point. I put 4 with no equal to sign or a parentheses if it was in interval notation. And then 6. It starts at 4, it ends at 6. That was my second equation I found, 15x minus 30. And then finally, equation number 3, notice it starts at 6. Again, it's connected to the other one, so you can leave that as an open dot, so to speak, even though they both touch the same point. And it ends at 12. So starts at 6, ends at 12. And that is my last equation, 5x plus 30. Basically, what you want to think of here, and I'm going to try to use a different color pen here, is in between each one of these, you essentially have the word if. And by that, I mean you use the first equation if x is between 0 and 4. You use the second equation if x is between 4 and 6. And you use the third equation, 5x plus 30, if x is between 6 and 12. So let's just say I wanted to pick a number between any of these intervals. So let's say I picked the number 8. Which equation would I use for 8? Well, look at your domain. Where would 8 be? 8 is between 6 and 12. So I would use this one. What's 8 times 5? 8 times 5 is 40. 40 plus 30 would be 70. Look up here. 8 gives me the value of 70 for y, because that equation is the one that is used if x is between 6 and 12. Pick another number. Let's say 3. 3 is between 0 and 4, so I use this one. Well, what is 3 times 15 over 2? That'd be 45 over 2, which is 22 and a half. Look right here. That's about where that's at. It's not hard to guess that that would probably be 3 and 22 and a half right there. So this is describing first piece, second piece, third piece. That's why it's called a piecewise function. The only difference, if you had any of these portions here that might be curved, is you would have something like a quadratic maybe in one of these spots in here. Now, we may do some more with that later in the year for Algebra 2. My pre-calc kiddos, you should already know how to find some curves like a quadratic. But it'd be the same thing. You tell me what the equation is, where it starts, where it stops. What the second equation is, where it starts, where it stops. What the third equation is, where it starts, where it stops. All right, hope this helps a little bit. We'll do some more in class.